Welcome in. We can see that our learning outcome for this video is to learn about dimensional analysis, which will allow us to convert units within the metric system or other units, including exponents in those units. We talked about previously in our videos, each number that we report needs to have a value, some units, and a metric for precision. We've talked about the first and third on this list. Now we get to dive into our units. Whenever we write a number down, we need to include some units, otherwise it's meaningless. What does it mean if I am 7 tall? Well, nothing. 7 what? 7 hands, 7 feet, 7 inches. We need to include a unit, otherwise there's no context. In science, we have a base set of units known as SI units. These are not always the most convenient, but at least we have a standard to refer back to. We can always adjust these SI units to be more convenient by using prefixes, as we'll see in just a moment. Our base unit of distance is the meter. Our base unit of time is the second. Our base unit of mass is the kilogram. And there we go. That is what we will generally need for this course. As we said, our SI units are not always the most convenient, but that's okay. We can always adjust the size of our units by adding a prefix. This prefix changes the size of our base unit, and those prefixes are very generic. We can use them in front of any kind of unit that we want. Therefore, if we're talking about the mass of a human, we can say, okay, 63 kilograms, sure. But a speck of dust might be more useful in a different unit than kilograms because it's so small. Or alternatively, stars are so large that, again, kilograms might not be appropriate. Here is a list of SI unit prefixes. We don't need to memorize all of these, but there are some that I would like you to know. I'll try to highlight those here now. These prefixes between kilo and micro, they come up often enough that it's good to memorize. Other unit prefixes, I'll give you the definition on an exam if you need it, but I would like you to memorize at least a handful of these. As we know from our lives, not every property can be distance or time or mass, but that's okay. Other properties we can describe using a combination of SI units. So for example, volume is length times length times length. The SI unit here is going to be meters times meters times meters, which is going to be meters cubed or cubic meters. Likewise, for density, this ratio of mass divided by volume, well, our mass is going to be in kilograms, and our volume is going to be in cubic meters. So this SI unit gets to be referred to in kilograms per cubic meter. Now that we have introduced our system of units, we can introduce a new problem-solving strategy known as dimensional analysis. This is going to be incredibly useful. It will allow us to convert from one unit to another algebraically. Here's our strategy listed out. We can start by writing down our value that we know. We can set up a big fraction that cancels out the units that we have that we don't want to have anymore, and we'll leave behind the units that we do want to have. Then we can fill in values into that big fraction, which is going to be a true known ratio. And finally, we can do our algebra with both units and numbers. We have an example down below. If we want to find how many centimeters are in 3.5 inches, let's start with the value we know, which is, there it is, 3.5 inches. Now we want to set up our conversion factor and cancel out the units that we don't want. We don't want to know about inches, so let's cancel that out. In order to cancel out a unit, we need one of our units in the numerator of our fraction and another in the denominator of our fraction. Something divided by itself is going to cancel out. The unit that we want to know about is going to be centimeters. Let's make sure that that is in the top of our fraction so that it's left behind after inches is canceled. There we go, we're almost there. We have our inches canceling, we have centimeters left behind. Now we just need to fill in our values into this fraction. Sometimes I like to draw some parentheses to denote our conversion factor. Inside that parentheses, this has to be a true known ratio. So how many centimeters are in an inch, how many inches are in a centimeter, we need to fill those numbers in here. Good news for us, we know this definition. 1 inch is exactly 2.54 centimeters. So if you want to fill in some values, 1 inch is going to be equal to 2.54 centimeters. There we go. This is a true known definition. We get to fill that into our fraction. As we said, a unit divided by itself cancels. This centimeter has nothing to cancel with. So our final answer is going to be in centimeters, and we can plug this into the calculator. Once we have our value, we can also think about our units. Okay, got it. And our significant figures. All right, don't forget our multiplication rule. We should round this value just to 8.9. If you're asking why, well, we have 2 significant figures in our first number. This is a definition, so it is infinite significant figures. And okay, the smallest value is going to be 2 sig figs. Let's keep our answer just to 2 sig figs. Check one spot over. Okay, let's round this up to 8.9. Notice before we had this definition, 1 inch is equal to 2.54 centimeters. We can phrase this as 2 separate fractions. One is going to be useful in some circumstances. The other will be useful in other circumstances. We can write this right side up or upside down, depending on what units we need to cancel. Likewise, if you have another definition, milliliters compared to liters, well, we can write that right side up or upside down. Both of these are totally valid. It just depends on what we're trying to convert into what. A couple of pro tips here. Always write down your units. Even if it's a little extra work, it will save you from some silly mistakes. Try to make your letters and numbers and Greek letters look different from each other. Be ashamed to get confused by a 2 and a Z or something like that. We have a couple of practice problems here. I'll go through the first 2 as an example. 3 and 4 can be practice for you. All right, let's get to it. Question 1. Let's start with the value that we know. Next, let's set up our big fraction. And let's get rid of that unit that we don't want. And let's try to end up with the units that we do want. This looks good. We're going to cancel out kilometers. We're going to end up with miles. Now we need to fill in our values. And good news, we're told our definition. 1 kilometer is the same as 0.6214 miles. Now when we start to do our math, kilometers cancels with kilometers, miles doesn't cancel with anything, and we'll end up with our value in units of miles. Remember, we have to be smarter than our calculator. Don't forget about our significant figures. It looks like we're doing multiplication. We have to keep the fewest number of sig figs. Our value to begin with is 2 sig figs. Our conversion factor, most conversion factors are known with infinite precision or unlimited sig figs. So the fewest between 2 and unlimited is going to be just 2. And so here we go, 4.8 miles is going to be the same as 7.8 kilometers. For our second problem, we're starting with 0.825 meters. And we're going to have to convert into millimeters. Let's get rid of that unit that we don't want, and let's end up with the unit that we do want. Now, for metric system problems like this, I like to ask myself out loud, which one is bigger, a meter or a millimeter? Well, a meter is about 3 feet, and a millimeter is those tiny little tick marks in between the centimeters. So here, a meter is going to be much, much bigger. Let's put a 1 next to our bigger unit. All right, now if we have one of those big meters, we're going to have to stack up a lot of those teeny tiny millimeters in order to be the same. Exactly how many millimeters? Well, it turns out we get to memorize this. Exactly 1,000 millimeters are the same as 1 meter. I like to do it this way. It's not the only way to do it, but it helps me to avoid having our numbers upside down. We do want to be multiplying by 1,000, not dividing by 1,000. If you happen to make that mistake and put the numbers upside down, you're off by about 1 million, which isn't a great feeling. So any way to avoid that, I like to do. We can plug this into the calculator, get our answer, check our sig figs, and I think we're sitting pretty good here. 825 millimeters is the same as 0.825 meters. There are 2 additional problems on this slide. This is a chance for you to pause the video, challenge yourself, grab some pen and paper, and write down your answers. We're going to look at a couple more challenging problems like this. Sometimes we don't have a step to go directly from where we want to where we want to go. So we can try to do multiple steps in a row. I like to do this just as one giant string of conversion factors and plug them all into the calculator all at one time. And to help us out, we can make a map of our calculation. So for example, if you're trying to convert from centimeters to feet, I don't know how many centimeters are in each foot, but I do know 1 inch is the same as 2.54 centimeters. And oh, good thing I also know there are 12 inches in every 1 foot. So with that first definition, we can go from centimeters to inches. And with that second definition, we can go from inches to feet. And so if we're trying to do this problem here, converting 615 centimeters to feet, we can start with that value that we know. We can cancel out centimeters and get to inches. And then we can cancel out inches and get to feet. 1 inch is the same as 2.54 centimeters. 1 foot is the same as 12 inches. And there we go. We have our whole calculation set up. All those units cancel out nicely. Centimeters divided by centimeters. Inches divided by inches. All that's left over is feet, which is exactly what we want to find. All that's left to do is to plug into the calculator 615 divided by 2.54, also divided by 12, and we can get our final answer. As always, let's include our units and include our sig figs. In this case, we have 3 sig figs to start with, infinite sig figs in both of these definitions, and so we only get to keep 3 significant figures for our final answer, 20.2 feet. We can set up one of these problems as an example. If we're doing our pasta recipe, looking for 0.75 liters of cream, and we want to convert into cups, we can do that using the provided conversions. To set up our map, we know that we want to start with this 0.75 liters, and we want to end up with our units in terms of cups. Now it's our job to map together to connect these 2 pieces to each other. You can go from the beginning towards the end, or you can work backwards, or you can do both and try to meet in the middle. But let's look at the conversions that we know. This conversion from liters to quarts allows us to, as a first step, figure out how many quarts we have. This second conversion from cups to quarts allows us to convert from, well, cups to quarts, quarts to cups. That will allow us to connect here in a 2-step conversion. Step 1, we're going to cancel out liters and get over to quarts. If you have 1 liter, this is the same as 1.057 quarts. Second step, we want to cancel out quarts, and we want to end up in cups. Exactly 4 cups are in every 1 quart. We can plug this into the calculator and get our final answer. There we go. We get about 3.2 cups of cream in our pasta sauce recipe. Amazing. This is a really useful technique for converting units, and this is good for real life situations as well. We have one more practice example. This is for medicine, another real life useful example. Pause the video here, try to set up our calculation, and write down your answer on that pen and paper worksheet that you got in front of you. Okay, and finally, we have one last wrinkle that we can introduce into our conversion strategies. Sometimes we are doing conversions where our units have exponents, which means we can't just use our regular conversion because all of those units won't cancel. For example, if we're trying to convert from cubic centimeters to cubic inches, say we have 5 cubic centimeters and we want to convert to cubic inches, we can't just use our regular conversion like we saw before. The reason for this is because mathematically, centimeters cubed and centimeters don't actually cancel each other out. Instead, I'll show you 2 ways to do this. The first is by writing down multiple copies of this conversion factor. In order to cancel out centimeters cubed, we're going to need to have 3 copies of centimeters down in the bottom of our fractions. If we set up our math like this, centimeters cubed divided by centimeters, 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 now that cancels and we can get our final value. A second way to think about this is to set up the conversion that we know here without any exponents. And then we can add exponents, but not just to our units. We need to add that exponent to every single unit and every single number. Notice here, these are mathematically the same. So either version of this strategy is totally fine, adding exponents everywhere, or writing out multiple copies of those conversion factors. Okay, one last example and one last practice problem. We'll do this first one as an example. We want to switch from cubic inches into cubic centimeters. In order to cancel out our inches cubed, we need to put that at the bottom of our fraction. And we want to get to centimeters, let's put that at the top of our fraction. If you don't know the conversion between cubic inches and cubic centimeters, that's okay. We do know that 1 inch is equal to 2.54 centimeters. So we can fill in that conversion. And now we can add in those exponents. Not just to the units, but also to those values. With our calculator and our knowledge of sig figs, we can get a good final answer. We have one more practice problem at the bottom here. Again, let's pause our video. Let's try to challenge ourselves and do this problem on our own. Congratulations, we've tried to accomplish our outcome here, converting units within the metric systems or other units, including our square and cubic units. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.